at the top of the worksheet today, it says, suppose you bought a 36-foot rope and wanted to cut it into 4 smaller ropes of equal length. So I have a 36-foot rope, and I want to cut it into 4 equal lengths. How would you do that? With scissors? Okay. What would be an easy way to cut a rope into 4 identical pieces? Divide it by 4 how? I mean, physically, what would you do? If I gave you a rope, I said cut it into 4 equal pieces. I would fold it in half and cut it. And then take each of those halves and fold it in half again. Okay. So how long would each rope be? 9 feet. So this is 9 feet, this is 9 feet, this is 9 feet, and this is 9 feet. What we have here, 36 by 4. Yeah, you take a 36-foot rope, you divide it by 4, you get 4 9-foot lengths. So it says, represent this as a multiplication and a division equation. So if I have 4 9-foot ropes, I end up with 36 feet. Okay, so that's the second question. How would I represent that as a division problem? 36 divided by 4 is 9. Okay, now let's put this in the context of a multiplication box. And this is a really interesting box. It's a 1 by 1, 4 and 9, and 36 goes in there. Okay, well, if I was working backwards, what if I had 36 in the box and 4 to the side? How do I know that 9 goes on top? If you pull out if you pull out a 4, what's left? 9. And when we say pull something out, we're talking multiplication. So in here, it's like saying we have 4 copies of 9. Okay, I'm pulling 4 of the same thing out, and each one has a length of 9. That's what we're going to do with the polynomial box. And you need to understand that 4 times 9 is 36, and 36 divided by 4 is 9. You can sort of rearrange multiplication and division, right? Okay. So, for this first one, I'm going to put 2x on the side and 4x plus 5 on the top. So this is the first problem under using polynomial multiplication. Okay. What goes in each one of those boxes? This would be 8x squared, and the next one would be 10x. Now, do I need to simplify anything? I don't have any like terms. So the answer is 8x squared plus 10x. Okay. Coda, does that remind you how to use the multiplication box? All right. So let's go backwards. Down below, you see 8x squared plus 10x over 2x. How do we do that backwards? Well, I put this on the left side, 2x, and you're going to find out that you're never quite sure how long the box is going to be when you start. That's what the problem said to do. So, okay, let me show you this. Let's call this A, and we'll call this B, and we'll call this C. So A times B equals C, correct? But C divided by A is B. I'm just rearranging it. So I'm going to take this and I'm going to put it right here. 8x squared. What do I take out of that 8x squared? 2x. So if I take out a 2, what's left? 4. And I take out an x, what's left? An x. If you pull out a 2 and an x, I have a 4 and an x left over. Does everybody understand that? Okay. So now I put this in the box, 10x. If I take out a 2 and an x, what's left? 5. And you'll notice this matches this, this matches this, and this matches this. So we've spent a lot of time multiplying polynomials by putting them in the box. Now we're going to start dividing polynomials out of the box. We'll use the box to do division. All right, the next one. I want you to put x minus 7 on the left, and then x minus 5 on top. Now this is a little bit trickier. Well, that's what the problem says. Do you see that? The second multiplication? Right, we'll get to the bottom in a second. What goes in this first square? X squared, and then minus 5x, minus 7x, and 35. And there's something that happens here that didn't happen last time. I have to combine like terms. Does x squared have any like terms? Nope, so we just write it down. Do the x's have like terms? Yes. Minus 12x, and then plus 35. That's the answer to the multiplication. Now let's go backwards. I want to put x minus 7 on the left. And once again, when you're doing division, you're not sure how long the box is going to be. And sometimes the box is longer than you think it should be, and sometimes it ends up being shorter. So you're never quite sure. And this is a little bit tricky. Okay? I'm going to close off the first column, and I'm going to take the x squared term, and I'm going to put it right here. Okay? What do I do with that x squared? You take an x out on the left, and what's left over? X. Now what do I do? Not yet. Nope. So if you weren't looking at this, if we just look at this box, as it's written, can I figure out any of the empty spaces? And that's where the trick is. We have to fill in empty spaces. Which empty space can we fill in? The bottom left. I can figure out this answer. How? It's x times negative 7. Does everybody see that? So without looking over here, if I know that the top is an x and the bottom left is a negative 7, then I also know that this is negative 7x. Okay? Once you finish a column, you add another column. Add another column. Now what? And this is the hard part. Well, I know what is supposed to go there. What is supposed to go there? Negative 5x. If we look at our other box. Okay. When you do division, you have to look at the diagonals. So, this diagonal is separate from this diagonal, which is separate from this diagonal. Right. So my first diagonal has to include nothing but x squareds. My second diagonal has to include nothing but x's, and my third diagonal has to include nothing but constants. So in that middle diagonal, those two boxes must equal negative 12x. And that's the hard part. This diagonal has to equal my x squared term. This diagonal has to equal my negative 12x term. and this diagonal has to equal 35. Well, and don't do them out of order, okay? Because you're going to find out sometimes it doesn't work. And we'll get to that later. But does everybody understand that I put my x squared in, I use that x squared to build the rest of the column, and now it's sort of like a puzzle. No, it's not. Yes. Yeah, you will have the equation, right? Down here, you have the equation and you have the left side. Your goal is to find the top. So over here, I know that this one and this one have to add up to be negative 12. I already have negative 7. What else do I need? Negative 5. So negative 5x. Now, does this plus this equal that? Yes. Okay. Once I fill that in, then I just kind of play that game. I pull out an x. If you take an x out, what's on top? Negative 5. And then I do negative 5 times negative 7, and I get 35. Did it match? Yes. So my answer is x minus 5. And we have just done division. Okay. That's the answer for the division, the second division problem. Okay. Now let's see if we can use the box and get the answers without doing the multiplication beforehand. So look at x to the third minus 10x squared plus 23x minus 14 divided by x minus 7. What do I put on the left side? X minus 7. So x minus 7. And I don't know how long this is. I'm not sure. Okay. What goes in the very first square? X to the third. What do I do with that x to the third? Take out an x. When I take out an x, what goes on top? X squared. And then what can I do with that x squared? Multiply it by negative 7, and this is negative 7x squared. Now, once you finish a column, you add another column. Okay. Okay, good question. This is x to the third. Right. The left side says I pulled out x. So this goes here, and then you just use the multiplication rules to fill in the rest. So if you take out an x, it's x squared. So x times x squared is x to the third. Right. So the first square is given to you, and you use the box to figure out the rest of the puzzle. Yeah, yep, over and over and over. So we add a column. Now, these two have to add up to be negative 10x squared. I already have a negative 7. I need negative 3 more. Does everybody understand that? These two squares must add up to negative 10. I already have negative 7, so I need negative 3 in addition in order to reach negative 10. Negative 3, and notice it's x squared. Now, what goes above that? Negative 3x. Because I'm taking an x out, and the leftover is negative 3x. Now what? Now I do the multiplication. Negative 3x times negative 7 is 21x. I finished the column, so now I add another column. Now I have a new diagonal made up of x's. I have 21x, and I need to create 23x. I need to add 2 x's. So 2x, and if I pull out an x, what's left? Plus 2, and then 2 times negative 7 is negative 14. Is that what I was looking for? Yes. Is that answer right? Look at the multiplication above it. Did we get the correct number? We did. So that x squared minus 3x plus 2 times x minus 7, you can cross that off. Just run a line through it so we won't grade it as incorrect. So these two on top you can scratch out. They're just there to tell us the answers. Okay? I want you to try the next one on your own. So try 15x to the third minus 26x squared plus 43x minus 14 divided by 5x minus 2. So I'm going to pause the video and then wait for you to work for a little bit, and then I'll show you how to solve it. When we set this up, 5x minus 2 goes on the left. I don't know how many columns there are, and I've written the numerator up there on the right. So your first step is always put this in the top left. So 15x to the third. Now I pull a 5x out of that box, and what's left? 3x squared. Does everybody understand that? Now I take that 3x squared and I use it to finish the column. 3x squared times negative 2 is negative 6x squared. Once you finish a column, you add another column. And then you start looking at the diagonals. This diagonal is my x squared diagonal, and it needs to add up to negative 26. Or subtract. I mean, no, it's add or subtract. Multiply is when you do top times side. But when you're doing diagonals, it's all addition or subtraction. So I have negative 6x, and I need negative 26x. X squared, thank you. So I need another negative 20x squared. If I pull a 5x out of that, I'm left with negative 4x. Now I use that negative 4x to finish the column. Negative 4x times negative 2 is 8x. Is everybody all right with that? Negative 4 was created by taking a 5x out of there. So negative 20 divided by 5 is negative 4, and x squared over x is x. Now I add a column, and I look at my next diagonal. That diagonal needs to add up to be 43x. I already have 8. How many more do I need? 35x. Rinse, lather, repeat. 35x, we pull out a 5x, what's left? Plus 7. 7 times negative 2 is negative 14. Does this match negative 14? Yes. Okay. Now, I'm going to make it just a little bit harder because I like to. Let's go back to the rope problem. What are the chances if you take a length of rope and you divide it by 4, it's going to end up being exactly a whole foot equivalent? Right? Take a rope, cut it in 4, measure them. What's the chances that it's a whole number, like 6 or 12 or negative 2? Pretty small. Chances are we'll have some leftovers. So let's rework the rope problem using 37 feet. 37-foot rope, cut it in half, cut it in half, cut it in half. Okay, let's use the box. 37. If 37 is in the box, can I pull a 4 out? No. But is there a number close to 37 that I can pull a 4 out? So let's change this. Instead of 37, I'm going to say 36 plus 1. So draw that box. Put a 4 on the outside. Can I pull a 4 out of the 36? 9. Does 4 go into 1? No. So back in your elementary days, you did this. 9 remainder 1. Okay? They teach you 9 remainder 1, and it makes absolutely no sense. Let's think of it in the rope story. How big is each rope? Each rope is 9 feet remainder 1. It is 9.25, but where does the 0.25 come from? You split the 1 into 4 pieces. So, here's what you do. You do the division, and you find out it doesn't work the way you want it to. You have a remainder. The way we deal with the remainder is we take 9, and we add the remainder, but it's not really 1. It's 1 cut into 4 pieces. 9 and 1/4. Does that make sense in terms of a rope? 9 1/4. So 9 feet, 3 inches. Okay? So whenever you're doing division and you end up with a remainder, you write your answer, and then you write plus, then you write your remainder, and then you divide it by the original divisor. Right? So this goes there, this goes there, this goes there. Okay? So if we have x to the third minus 2x squared minus 19x minus 20, and we divide that by x plus 3, I put x plus 3 on the left, and once again, I don't know how many columns there are. What's my first step? I put x to the third in the first square. What goes on top? X squared. If you take out an x, you're left with x squared. Cody, you get that? Okay. Now I use x squared to finish the column. X squared times 3 is 3x squared. Add a column. Now I look at my x squared diagonal. I have 3x squared, and I need negative 2x squared. So to turn a 3x into a negative 2, I need to subtract 5x squared. Does everybody understand that? I have negative 3, I have 3x squared, and I need it to equal negative 2x squared. So what do I choose to go from 3 to negative 2? And the answer is negative 5. Negative 5x squared. Now I pull out an x. What's left over? Negative 5x. And I use the negative 5x to finish the column. So negative 5x times 3 is negative 15x. Then I look at my diagonal. This diagonal needs to add up to be negative 19. So I need to subtract 4x. Does everybody understand why it's 4x? Negative 4x. Negative 4x. Now I pull out an x and I get minus 4. And negative 4 times 3 is negative 12. That's not what I wanted. So I'm going to draw a line here. Once you get to the constant right here, right? Once I have looked at all of these numbers except the last one, I'm going to draw a line right there. Everything after that becomes a remainder. Okay? Anything that is on the right side of that red line is a remainder. So I have negative 12, and I'm going to add another column, and this need to add up to be negative 20. So how much more do I need? Negative 8. But can I take an x out of a negative 8? No. And that's the remainder. Okay, so instead of saying x squared minus 5x minus 4 remainder negative 8, like we did in elementary school, nope. The rule was I add the remainder divided by the original x plus 3. That's what we did with the rope, right? I took that leftover 1 and I added it, and then I took the 1 and divided it by 4. Okay, so you guys try the next one. It will have a remainder, and your job is to find the numerator, or, well, find the quotient, and then figure out what to do with the remainder. I put my divisor on the left, 5x minus 2, and then I've written the equation up on the right of the numerator. My first step is to put in 15x to the third. And I pull a 5x out of 15x to the third, and I'm left with 3x squared. Oh, did I mess up? Oh. What did I do? Oh. I messed it all up. Okay, so this is a 12. And the rest is right. Okay. Thank you. Here we go. 12x to the third. I pull out a 4x, and I'm left with 3x squared. I use the 3x squared to finish the row. Negative 9x squared. Now this diagonal needs to add up to negative 29. I already have a negative 9. I need an additional negative 20. Negative 20x squared. I pull out a 4x, and I get negative 5x. I use that negative 5x to finish the row. 15x. Once I finish the row, I add a column. 15x and this box need to add up to 23x. So I need 8x. It's just 8. Did you have a negative backwards? I take that 8x and I pull out 4x, which leaves me with plus 2. And 2 times negative 3 is negative 6. And once I get to the constant, if there are any more columns, they will be remainders. My constant is negative 6, but the equation says positive 8. I need to add 14, and it goes in a remainder box. And you can tell it's a remainder because can I pull a 4x out of a 14? No. So we have remainder 14. The final equation is going to be 3x squared minus 5x plus 2. What do I do with that remainder? I put plus 14 over the original divisor, 4x minus 3. Okay, and before you get started on the back, what if my remainder is negative? I would always, if you had remainder negative 14, never make this subtract. Just put plus and then make the numerator negative. Because eventually, we're going to have remainders that look like equations. We'll have a remainder that will be x squared plus x plus 3. So just put plus and then write the remainder as is, and then put it divided by the original divisor. Okay, now that's not going to happen today. So your assignment today is to do 1 through 15. Okay? Good luck. The answer